Now we're going to look at some real life problems. So this is how you might use trigonometry in the real world after you leave school. So, section B. Question 4. A ladder 3.6 metres long rests against a windowsill which is h metres above the ground. The ladder makes an angle of 65 degrees with the ground. Find the value of h. Give your answer to one decimal place. Now this is more likely going to be the kind of question you get in the exam. They don't usually just give you a triangle and say find this length. They will pretty much always give you some kind of story because it's functional, and it is up to you to be able to read that and understand what you've got to do. So the best thing to do first is to make a diagram. So you've got a ladder 3.6 metres long resting against a windowsill. So the windowsill is on a wall. So let's say that's a wall and there's a windowsill. You've got a ladder there 3.6 metres long. Obviously you've got the floor there. The ladder makes an angle of 65 degrees with the ground. So there's the ladder, there's the ground, so the angle here is 65 degrees. It also says it rests against the windowsill which is h metres above the ground. So that windowsill there, there's the ground, so that's h from there to there. We need to find the value of h, so we're finding how high the windowsill is. You can see straight away when you've done the diagram, you've got something that resembles a right angled triangle. So as soon as you've done that diagram, you don't really have to worry about the story anymore. All we know is that we've got to find h, which is an opposite. Okay? So remember your three triangles. Some people have different ways of remembering them. SOHCAHTOA is one. Just remembering a word that's saw, ka, to, wa. Some people do that. Other people prefer sex on holiday comes after having tons of alcohol, apparently. I was told that when I was at school. I never actually used it. I preferred SOHCAHTOA. Anyway, we've got to find h. It's an opposite because it's opposite the angle. And we've got 3.6, which is the hypotenuse. Now, don't be put off by the fact that there's a h. That h, they have chosen h because it means height. Obviously, we've got h's involved in these things here, but they stand for hypotenuse, which is obviously this side here, not that side there. So don't let it confuse you. H means that length, which is not the hypotenuse. So that length is an opposite, O, O, and this length here is the hypotenuse. So which one has opposite and hypotenuse in? It's this one, the sine one. So we want to find the opposite, cover up the O. So we're going to do the sine of the angle multiplied by the height. So h, multiplied by the hypotenuse. See, I nearly did it myself. So h is sine 65 multiplied by hypotenuse 3.6. Now, I could have written that slightly differently. Some people prefer to write it like this. So what I'm about to write now is just another way of writing this. So it's not something, you don't have to do it as well. You can do one or the other. Some people prefer doing 3.6 sine 65. And the reason is because of on the calculator. If I do sin 65 now on the calculator, sin 65, you can see it automatically opens up a bracket. Now if I type times 3.6 in, I'm going to get the wrong answer. And the reason is, it's thinking I want the sine of the angle which is whatever 65.3.6 is. Okay, so we don't want the angle 65 times 3.6, we want the sin of the angle 65 multiplied by 3.6. So remember to close off the bracket times 3.6. Now, as I was saying, this what I've written here some people prefer writing it like that because, let's just check the answer, 3.2. On your calculator you can actually just do 3.6, press sin, and then press 65. I can close the bracket or I can leave it, it doesn't really matter. 3.2, same answer. Okay. So it all depends on what you prefer to do. I'm going to stick with this method simply because it's in the order of whatever's in the triangle. So you get 3.2627. We wanted h, the height, to 1 decimal place, which means I'm cutting it off there after 1. It's not significant figures anymore. 1 decimal place. 6 is large, so 2 will go up to 3. So it ends up being 3.3 meters, because that's our unit. Okay. Next question. We have another real life situation that we're all going to encounter. A space shuttle is rising at 650 meters per second. Andy is 3 kilometers away from the launch pad. What is the angle of elevation of the space shuttle after 5 minutes? Give your answer to 1 decimal place. So it's 1 decimal place and we want an angle after 5 minutes. Because notice, it doesn't tell us how high the shuttle is. It tells us that it's rising at 650 meters per second. So we need to work out the height after 5 minutes. Okay? So, how do we do that? It's rising at 650 meters every second. So if we take 650, that's how high it's going to be after 1 second. So how high will it be after 1 minute? Well, 1 minute is 60 seconds. So I'm going to times that by 60. So that's how high it's going to be after 1 minute. We want 5 minutes, so now I'm going to times it by 5. 650 multiplied by 60 multiplied by 5, which is 195 kilometers. But remember, it was 650 meters per second. So if I actually calculate that, 650 multiplied by 60 multiplied by 5 is 195,000 meters. Okay? And all I've done to turn it into kilometers is divide it by 1,000. Divided by 1,000. 195 kilometers. So that's how high the space shuttle is. So if I draw a line like that, this is the launch pad down there. Up here is the space shuttle. That. And it is 195 kilometers high. Andy is 3 kilometers away from the launch pad. So let's say that Andy is here. This is obviously not to scale. So there, 3 kilometers away from the launch pad. There's the launch pad, there. What is the angle of elevation of the space shuttle after 5 minutes? That means, let's say Andy is here. It basically means if he's looking up at the space shuttle, what is his angle level with the ground? There's the ground. If the ground is 0, what is this angle here? How far back does he have to tilt his head up to be able to see the space shuttle? That's basically what it means. So we're going to find this angle there, which is an angle of elevation. Elevation means looking upwards, like elevators take you upwards, although they always take you downwards as well. But elevate generally means going upwards. So, we've got to find an angle, we've got an opposite, we've got an adjacent. Opposite and adjacent. You can see, opposite and adjacent is in the tan triangle. I'll write that in again. See, T-O-A. We want to find the angle, so that's the tan of the angle there. We can find the tan of the angle by doing the opposite divided by the adjacent. So that's 195 divided by the adjacent, which is 3. And remember, if I work that out, that will be the tan of the angle. So if I want the actual angle, I'm going to have to do tan to the minus 1 of that. So x equals tan to the minus 1, so shift tan 195 divided by 3. And that equals 89.11. Shouldn't really say 11. 1, 1, 8, 5, 9, 6. It wanted one decimal place only, so it's 89 point. Cut the rest off. 1. That one's a small number. Remember, small numbers being 0, 1, 2, 3, and 4, which means this number there, this digit there, stays the same. So it's 89.1. And it's an angle, so degrees. 89.1 degrees.